Context-free languages. Context-free languages or CFLs are generated by context-free grammar. The set of all context-free languages is identical to the set of languages accepted by the pushdown automata. And the set of regular languages is a subset of context-free languages. An input language is accepted by a computational model if it runs through the models and ends in an accepting final state. All regular languages are context-free languages, but not all context-free languages are regular. Most arithmetic expressions are generated by context-free grammars, and are therefore context-free languages. Context-free languages can be used in multiple areas of computer science and linguistics, such as natural language processing and computer language design. CFLs have various properties, but in this video we're going to focus on CFL's closure properties. CFLs are closed under union, concatenation, clean star, reversal, homomorphism, and inverse homomorphism, but it is not closed under difference or intersection. Context-free languages that are generated by context-free grammar have the form A tends to rho, where A belongs to n and rho belongs to T union of n whole star, where n is non-terminal and T is a terminal. Union closure property. In union closure property, let's consider two languages, L1 and L2. Both of them are context-free languages. So in this we are trying to prove that L1 union of L2 is also a context-free. So let's consider an example. L1 is the given language and L2 is the given language. So L3 is equal to L1 of union. L1 union L2 gives an, bn, c bar n. So that is in other words, if L1 says number of a's should be equal to number of b's, and L2 says number of b's should also be equal to number of c's, the union says that either of the two conditions is to be true. So in other words, if L1 says A tends to B and L2 says B tends to C, then in L3 says A tends to C. So in all, it is closed under union. So L3 is also context-free language. So CFLs are closed under union. Concatenation closure property. So as the previous property, let's consider, and even in this property, let's consider two languages, L1 and L2. So, and what we're trying to prove here is L1 concatenating L2 is also context free. So let's consider language L1 is equal to A par n, B par n greater than or equal to 0, and also L2 is equal to C par m, D par m greater than or equal to 0. So L3, let's consider another language L3, which is a concatenation of L1 and L2. So L3 must be equal to A par n, B par n, C par m, D par m, where m is greater than or equal to 0 and n is also greater than or equal to 0. So in other words, let's say L1 says number of A's should be equal to number of B's, and L2 says number of C's should be equal to number of D's. The concatenation says that the first number of A's should be equal to number of B's, then number of C's must be equal to number of D's. So it is kind of like barter systems of A is equal to B, then only it is AC is equal to D. So from this we can create a PDA which will first push A, pop B, push C, then pop D. So in a way it is accepted by pushdown automata. hence it is context free, as every language accessed by push down automata is context free. Therefore, context free languages are closed under concatenation. Clean closure property of CFL languages. In this property, let's consider a language L1 that is context free. In this, what we are trying to prove is that L1 star, or the clean counterpart of L1, is also context free. So let's let L1 is equal to A par n, B par n, where n is greater than or equal to 0. Now L1 star is equal to A par n, B par n, or n greater than or equal to 0 whole star. In way, let's consider A and A pars A star, or like an exponential form like E and E par E star, E par star. So in a logarithmic format, both are same. So in the similar format, in the clean closure property, L1 and L1 star are similar. So CFLs are closed under clean closure property. Reversal closure property. So in this property, let's consider a language L1 which is context free, then a language L1R which is a reverse language of L1 is also context free. Let's take an example. So let us consider a language L which has an string s is equal to 0s1 slash 01. The reversal of this grammar L of G has a grammar as a string s is equal to 1 s0 slash 10, which is the reverse of the previous language 0s1 slash 01. So considering this can be pushed into a push down automata, this reverse language is also context free. Hence, the reversal of language, the reversal property is closed under context free languages. Let L be a CFL with grammar G. Then let H be a homomorphism on the terminal symbols of G. Now construct a grammar for H of L, which is a grammar for the homomorphic symbols by replacing each terminal symbol of A by H of A. So let's consider an example for homomorphism. So G has a production S which is equal to 0s1 slash 01. Now H is defined as H of 0 is equal to AB, where H of 1 is equal to epsilon. Now let's consider grammar H of L of G has the grammar productions S is equal to AB capital S slash AB. So in other sense, it is closed under homomorphism.